Hello everyone, and I'm Prashant Chaudhary, and I'm going to present a PPT on the application of AI, artificial intelligence, in chemical engineering. So, as we know, that a major shortcoming of traditional strategies is the fact that solving chemical engineering problems due to its highly nonlinear behavior of chemical processes and is often impossible or very difficult. So today, artificial intelligence techniques are becoming useful due to simple implementation. So uh, artificial intelligence techniques are becoming useful due to very simple implementation, easy designing, its generality, and the robustness and the flexibility of the model of AI. So it is very useful in the at least the Department of Chemical Engineering. So the AI includes various branches, namely artificial neural network, fuzzy logic, genetic genetic algorithm, and expert system and hybrid system. They have been widely used in various applications of the chemical engineering field. Uh, so AI includes various branches and they have been used in various applications of the chemical engineering field such as modeling and process control, the classification, optimization, fault detection, and diagnosis. So AI application in chemical engineering have increased dramatically in recent years, and it is shown that complexities of conventional approach when dealing with chemical processes are highly nonlinear and can be tackled through applications of artificial intelligence methods. So there are a number of applications of chemical engineering uh, of AI in chemical engineering. So generally, there are two types of modeling approach in chemical engineering. First, namely mechanistic, that is white box first principle approach, and the second one is AI-based approach like ANN, artificial neural network, and fuzzy logic methods. And there are also ANFIS, which is kind of derived from the fuzzy logic method. So, in the mechanistic approach, fundamental physics and chemical laws, such as the conservation laws, construct the basis of this model. And this approach contains algebraic and differential equations which involves masses, energy, and momentum balance. And due to the large number of variables affecting the process behavior and the complex mathematical equation governing the system, many chemical processes are non-linear and complicated. So due to that, it is hard and sometimes even impossible to present them by mechanistic model. So even if a model has been developed in by mechanistic model, it might be impractical to solve or identify its parameters. So we see that it's very unlikely and very hard to solve problems in chemical engineering based on mechanistic model. But there is also uh, a new model which is derived from AI models. So AI-based techniques, which are now variously used in chemical engineering, have demonstrated their superb ability to have received much attention from chemical process modeling. And these techniques for which developing detailed knowledge of the process is less concern, and also it has lesser drawbacks from the mechanistic approach, and it is very easier to solve. So let us find out what is the steps for developing AI models. So basically, it is way too easy for solving chemical processes by AI models. And the first step of developing an AI-based model is nothing but uh, AI model is defining the input-output variables of the system, which is to be modeled, and afterwards, according to the experimental data or the knowledge of the governing phenomena, the model is developed. So that's only the two methods for developing any AI model. So we have to we have to put the input and output variables of the system, and we have to model the model developed sorry we have to develop a model according to the experimental data, and this is all in the convention in the AI approach of in AI in chemical engineering. And now Prashant will speak after that. Thank you.
Hi, this is Prashant, 19MA40012. So I will discuss the application of AI in the optimization of chemical process. Um, so the chemical process optimization has its origin in linear programming at the beginning of 1960. This problem is finding the best solution from the variety of effective alternate of design or operating variable in order to minimize or maximize a desired objective function. In general, the objective function can be minimization of operating cost in undesired material production or maximization of the energy efficiency, the life operation productivity, the profitable and safety and reliability of the plant. So most chemical processes are non-linear and complex. So there are many solutions in the optimization problem. Such problems are often too complex to be solved through gradient-based optimization approach. So evolutionary algorithm like GA, harmonic search, particle swarm optimization, and so categorized in AI-based method, that is generic population-based meta-heuristic optimization algorithm, are capable of efficiency finding the optimal solution in complex problem such optimization of chemical process. And now application of AI technique in fault detection and diagnosis of chemical engineering. Let's discuss how is it work. Now a fault is defined as a deviation from accepting range of observable variable or calculated parameter that is referred to as a failure. So a failure can be described as a diversity of malfunction in the real plant which can be caused due to instruments failure, a disturbance in plant parameter, uncertainty. The abnormal condition in a plant can be result in the financial losses, and therefore in the chemical process, fault detection and diagnosis have been the focal point of many researchers in various fault detection and diagnosis strategies have been presented in the many literatures. So the fault diagnosis system should possess desirable characterizations such as quick detection, isolability, robustness, and multiple fault identifiability. So one of the intelligent fault diagnosis technique is a neural network system. Because of their high potential of capturing nonlinear relationship, neural network represent a powerful tool for the fault diagnosis. So in the fault detection based on neural network, the number of neurons in the input and output layer are equal to the number of measured variable and number of potential fault in the process respectively. The output of the neural diagnoser are binary variable representing the occurrence of fault or the lack of fault occurrence. So, another fault diagnosis approach of AI technique is a fuzzy logic, which is applied in a chemical process. In a fault diagnosis based fuzzy logic, the fuzzy relations between fault and system are assumed to be from one to many. So one fault may cause several symptoms. For example, you can check this chart. This is chart. Uh, this is a chart of schematic diagram of fuzzy fault detection scheme. So, although the network it is powerful tool for the fault diagnosis due to its ability in capturing the non-linear relationship with the no heuristic, no heuristic reasoning about process. So, it requires a large number of data. So, corresponding to various operating conditions in which the effect of various fault exists. So, on the other hand, the fuzzy diagnoser system express the heuristic knowledge between the symptoms and their corresponding fault of the process such as Linguist rule and does not require any quantitative data sets corresponding to the history and trends of the system under any operating condition. So And the disadvantage of the fuzzy diagnoser, that is okay. So now the disadvantage of the fuzzy diagnoser in the managing heuristic and knowledge based rule is more difficult and time demanding and sometimes even impossible for the plant wide integral process. So therefore, neurofuzzy diagnoser application is chemical plant are proposed in some literature. Uh, so you can go through this, and in the following eight techniques are presented for the various purpose. So process control, fault detection, and chemical process. So and you can so one of the separate technology for virus removal from water to manipulate effluent is the application of membranes, and conventional modeling approach for the predicting membranes performance suffer from various limitations such as lack of predictability, fault model, or complexities of estimating the properties of the membrane surface and membranes interaction. Thank you.